Hello, welcome to the course Mathematical Foundations of AI and DS. I am Dr. Vinay from NIT Trichy. In this video, we are going to study about probability and probability distributions. In mathematics, one of the main concepts which is directly used in machine learning or AI in general, if I talk about, is probability. It has lot of application in AI and DS. Let's try to understand how and where probability is used. Okay, so when we talk about probability and distributions, they are very foundational to AI, ML and data science because we deal with lot of uncertainty. Okay, where is this uncertainty? Let me give an example to you. When you have a data set with you, there is high chances that there is lot of noisy data in the data set. When you gather the data, when you try to accumulate the data, you will have lot of noisy data in that. So when you have a noisy data, on this noisy data, if you build a model, there is chance that the performance or the accuracy of this model also will be uncertain. Why? Because you are trying to build an ML model on a noisy data which has lot of uncertainty. So you are trying to build a model on such noisy data. Therefore, the ML model which you are building will also be uncertain in nature. Now, when you have such uncertainty in your predictions, right, you quantify such uncertainty using the concept of probability. Right. So this is one direct application of where probability is used in machine learning. Right. So again, there are a lot of other tasks, there are a lot of probabilistic models available which we will be seeing in the due course. Right. So that one application is when they provide us mathematical framework for modeling uncertainty, also for making predictions and drawing inferences. Probability is used from across every stages, from data pre-processing to model building and evaluation. We have probabilistic models. We use probability to represent uncertainty. We use probability to tell the to evaluate the model. Right. So there are a lot of applications. If I talk in general about different applications, so the first one is data modeling and representation. Right. This is what I was talking about. You often have noisy and uncertain data. Right. So when you have such uncertain data, when you have noisy data with you, right, probability distributions help us in identifying the likelihood of different outcomes. Okay. So the model which you are trying to form, right, so what outcome will it give me? What is the likelihood of getting this outcome? When there is uncertainty in the data, what is the uncertainty? What will be the uncertainty in the model or in the outcome? So there we try to use probability. Right. So and many of the ML algorithms rely on probabilistic assumptions to make predictions or classify data points. We use probability at every point. We have probabilistic regression model. Regression generally is used for doing predictions. Regression analysis we have simple linear regression, multiple linear regression. So we have another model called probabilistic regression model which uses probability to do the predictions. So directly or indirectly there is lot of application of probability in the ML algorithms. Generative models, right. So these generative models learn the joint probability distribution of the data to generate new samples. So when you want to fill the missing data, when you want to generate new samples, we have to use joint probability distribution. So we will study what is joint probability as well. So this way it is used in AI and DS. And again, the most common one, wherever there is uncertainty, it need not be AIML, it need not be only machine learning or data science. Wherever there is uncertainty in the world, in any task, you can use probability there. Right. So AIML models often need to quantify confidence in predictions. You will tell, I am 80% confident that this model is classifying it as a rat than compared to another animal, bat, let us say. Right. So we have to, when we do predictions, we quantify it in terms of confidence level, and this confidence level can be given with respect to probability. Like this, there are n number of applications where probability can be used in AI and data science. Let us see few probability concepts. Probability distribution. What is a probability distribution? Right? I am conducting an experiment. Okay, I am conducting an experiment. I generate outcomes. Right? So that is called an event. Conducting an experiment is called an event. Okay, before that, let us see probability distribution. It is a mathematical function that describes the probability of different possible values of a variable. So when I conduct an experiment, let us say I am tossing I am flipping a coin. So I know I will get either tail or head. Okay, so probability distribution is a function that describes the different possible values. What is the probability of different possible values? See, tail one time I can get or head I can get. I can get this or get this. What is the probability of getting tail and head? It is 0.5. 1 by 2 chances I will get tail, 1 by 2 chances I will get head. So probability distribution is a mathematical function which describes the probability of different outcomes. Okay, generally they are depicted using graphs or probability tables, something like this, right? So this is the probability table, outcome and the probability. Okay, head 0.5, tails 0.5, right? So this is about probability distribution. Now with respect to probability distribution, we talk about an important concept called random variables. What is this random variable? Okay, variables that follow probability distribution are called random variables, right? So let us say just an example, we represent it like this. Okay, x is a random variable, it follows d. D is any distribution, d could be any distribution, we represent it like this. Okay, so random variable is a variable that follows a probability distribution, right? So x is a random variable, this means follows distribution, it means follows distribution. So simple example is given here. See, x is a random variable, it follows normal distribution with the parameters mean and variance, Okay, next, types of probability distributions. We have two types of probability distributions. First one is discrete, second is continuous. Discrete probability distribution and continuous probability distribution. So what is this discrete? Let us see that in detail. Anyhow, countable outcomes, any event which happens, if it has countable outcomes, then we can say it is discrete. For example, if I roll a dice, I know the outcomes will be from 1 to 6. It is countable. N number of times you do, either it will be any one number from 1 to 6. Okay, that is countable outcomes. Continuous probability distribution means infinite possible values. Let us say, if I say heights of the students, in university. When I say this, heights of students in university, it could vary. There is no fixed number. It could be 176 centimeter, 165 centimeter, or 195 centimeter, or it could be 158.2 centimeter. It could be any number. We do not have any limit. Its infinite possible values are there. Why? There is chance, no, somebody can be this 171.2 centimeters, 171.3 centimeter, 171.25 centimeter. Like this, it could be n number of values. So the distribution which has infinite possible values are called continuous probability distributions, right? So discrete probability distribution, it's a probability distribution of categorical or discrete variable. Categorical means, when I talk about the gender of an student, I have male and female, categorical, right? So this is fixed, discrete, I can know, gender means true, we know that, right? So that way. Okay, so discrete probability distributions only include the probabilities of values that are possible. Values which are possible only we include them, right? Sum of all the probabilities 1 by 2. Let us take an example of flipping a coin. I get tail and the probability is 1 by 2. I get head, the probability is 1 by 2. If you sum up, it becomes 1. So sum of all the probabilities is 1. In the same way, if I roll a dice, if I roll a dice, I know that getting 1 is 1 by 6 chances, getting 2 is also 1 by 6, same way getting 6 is also 1 by 6 chances. If you sum up all these, we get 1, right. So, the sum of probabilities is always 1. So, the property here 0 less than or equal to probability of x getting x, summation of that is always between this. It means the x is a random variable, x is the outcome. What is the probability of x being 1 by 3? What is this? Sorry, x being, sorry, this case here x being 3. On a die, what is the probability of getting x is 3? It is 1 by 3. 1 by 3. That should be between 0 and 1. Yes, it is between 0 and 1. Okay, that is what the important property of discrete probability distribution. Same way, the another one we have is continuous probability distribution. So, here just an example which I was talking about, heights of the students or heights of the population, height of the people, it is continuous, there is no fixed value here. The probability, no, the outcome will always change. Okay. It can have any value between its lowest and the highest values. It can have any, generally if you say height is from 10 centimeters to 200, if you say, it can have any value between this range. Okay. Therefore, it includes every number in the variables range. Every possible number is included in the continuous probability distribution, right. So, this is about discrete and continuous probability distributions. Next, in probability we have two important principles which we have to study, sum rule and product rule. Sum rule and product rule. Let us try to understand what is the sum rule and product rule. Sum rule, right. It is used when we want to find the probability that either of two or more events occur. When we want to find out the probability that either of two or more events occur. Let us say there are two events A and B. Event means experiment which I am conducting. So, for any two events A and B, the sum rule states that P of A union B is nothing but P of A plus P of B minus P of A intersection B. Okay. So, this is the sum rule principle. We will try to understand this with an example. If A and B are mutually exclusive, it means they do not happen at same time. If there is no common point happening, there is no two events are happening common at same time, then this will be A intersection B will be 0. Therefore, P of A union B becomes P of A plus P of B. Let us say this, see, for mutually exclusive events, the events are like this. The outcomes of experiment A is this and this is B. There is no intersection between both of them. That is why for mutually exclusive events, mutually exclusive means separate, not happening at same time, right. Sum rule is P of A union B equal to P of A plus P of B, whereas in other case when they are not mutually exclusive, it is P of A plus P of B minus P of A intersection B, right. So, let us see an example problem. Let us try to understand what is sum rule with an example. Mary has two green shirts and 3 red skirts and 4 blue skirts. Okay. To choose from for her outfit today. She wants to choose one outfit, one skirt she wants to choose. She chooses a skirt randomly with each skirt equally likely to be chosen. Equally likely to be chosen means what is the chance of getting this is 1 by 3, this also 1 by 3 and this also 1 by 3. What is the probability that Mary chooses a green or blue skirt? What is the probability that Mary chooses a green or blue skirt? So, let us see. So, let us define the events G and B as follows. Because she chooses a green as well as a blue. So, let G be an event, Mary chooses a green skirt, blue be an event, she chooses, B be an event, she chooses blue skirt. Now, Mary cannot choose both a green or blue. So, the rule of sum applies here. She cannot apply both, right. So, G union B. Okay. Total how many skirts are there? You see 2 plus 3 plus 4. 2 plus 3 plus 4 is 9. Out of 9, what is the probability of choosing green? It is 2 by 9. What is the probability of choosing blue here? 4 by 9, because this is chances of getting. What is the chance of getting blue? 4 by 9. What is chance of getting green? It is 2 by 9. Out of 9, choosing 2, right? And are they mutually exclusive? Can they both happen same time? No. She can choose only one skirt at a time, not two, because it is given or here, right? Since it is given or here, it is 2 by 9 plus 4 by 9, that is equal to 2 by 3. We don't have any intersection here. So the probability that Mary chooses a green or a blue skirt, a green or a blue skirt is 2 by 3. So using some rule, we found out this. Let's see another, again the same thing I was talking about. If A and B not necessarily mutually exclusive, then this is the sum rule. We have P of A plus P of B minus P of A intersection B in case of not mutually exclusive events. Another problem, let's see. In a bag there are 34 marbles. There are 14 blue in the bag, and 4 of those marbles are both blue and stripped. Okay, 4 are blue and stripped. 16 marbles are stripped. Of those marbles, the same 4 marbles are both blue and stripped. Okay, so total 16 marbles are striped. Okay, now what is the probability that you draw a marble from the bag that is either blue or stripped? See, out of 34, 14 we are telling are blue, right? In this 14 and 4 of those are blue and stripped. So in this there are 4 which are both blue plus stripped. It means we are having 4 in this 14, we are having 4 stripped ones. Now in this 34, 16 are only stripped ones. Of those marbles, the same 4 marbles are both blue and stripped. It means these 4 are common in both. Okay, what is the probability that you draw a marble from the bag that is either blue or stripped? So how many are actually blue and how many total are stripped, that we have to find out. Only then we can apply our sum rule. Okay, here there is some common part. Why? It is blue also plus it is stripped also. See, and blue and stripped. So when and is used, you have to go for sum rule which are not mutually exclusive. So we will get P of A, we have to apply this P of A plus P of B minus P of A intersection B. So let's try to understand how we try to solve this. See, you understand the problem. You are trying to calculate the probability of marble being blue or stripped. Okay, or is important here. Or indicates that we are finding the probability of union of events. There are 2 events definitely we are trying to find out. Okay, let B be the event that blue marble is drawn. Okay, T be the event that stripped marble is drawn. Now the problem mentions that marbles can be both blue and stripped. This indicates that the events are not mutually exclusive. Therefore B intersection T also happens. It is the event that a marble that is not both blue and stripped is drawn. B union T means event that is either blue or a stripped is drawn. Intersection means which is both blue and stripped. So we have that data with us in the question. Now, so our goal is to find out P of B union T. How do you find out? We apply this formula. So we know. Again, from the data what it is given, 14 are blue is given. So drawing 14 from total 34, 14 by 34 plus how many stripped are there? 16 are stripped. That is also given to us. Minus there are 4 which are common, which has both blue and stripped. So 14 by 34 minus 16 plus 16 by 34 minus 4 by 34. Right? If you do this, it is 26 by 34, that is 13 by 17 is the answer. So using some rule you are trying to find out. Okay, we should be very careful while choosing whether they are mutually exclusive or not. From the question itself, it is very clear to us that there are both blue, there are 4 marbles which are both blue and stripped. So this gives an idea to us that about the whether they are mutually exclusive or not. So this is about some rule. Let's try to understand the product rule. Okay, let's try to understand what is product rule. The rule of product is a guideline as to when probabilities can be multiplied to produce another meaningful probability. Okay, so the rule of product is used to find the probability of an intersection of events. If you want to find out intersection of events, then we apply the product rule, right? So let A and B be independent events, then the formula of product rule is P of A intersection B equal to P of A into P of B. Okay, so let's see a simple example to understand product rule, how and where we use this. A six-sided fair die is rolled twice. Okay, what is the probability that both rolls result in 6? Right. So the question here is I am rolling it 2 times, and what is the chance that both it is 6? Right. So each roll is independent, each die roll is independent. The outcome of first roll does not affect the second one. They are not linked. No, I am rolling both at a time, maybe. No, sorry, not at a time. I am not rolling them both at a time. I am doing it 2 times. First one I am rolling once, again I am rolling the same die second time also. So they are not independent of each other, they are happening one after the other. Okay, now to get 6, first time to get 6, what is the probability? 1 by 6. First time getting 6 is 1 by 6. Now second one, first time getting 6 and second time also getting 6 is also 1 by 6. First time getting is 1 by 6, second time getting is 1 by 6 chances, right? So the probability that both times the result will be 6 is 1 by P of A into P of B, that is 1 by 36. Simple, right? We will see one more example to understand this product rule. In this example, if die was rolled twice, one after the other, what is the probability that both rolls result in 6? So first time getting 6 is 1 by 6, second time again getting 6 is 1 by 6. So what is the combined one? Both times getting 6 is 1 by 36. Okay, let's see another example, right? This is a very simple problem to understand what is product rule, right? So let's move into the most important concept, conditional probability, in our next video. Thank you.